Okay, so last time, so I'm recording here, I'm recording there, and I shared my screen. Do you guys hear me? The online people?
Yes.
Do you hear me? Okay, yeah. You see my screen?
Yes.
Okay, good. But the people here, they don't. You don't see the screen. Okay, so last time we looked at the finite state methods as a general way of doing the morphological analysis. Okay, I introduced a number of, well, actually I did not introduce anything because you already knew the finite state automata. It was kind of a review, finite state automata, and we looked at it, and formally we defined the finite state automata. That was the finite state automata. 5 elements, the set of states, finite alphabet, and start state, a number of except or final states, and the transition function, like the cross product of this Q, the step states, and the and the alphabet to Q again. We talked about this, and we gave some simple finite state automata examples, not related to morphology, something like that. Okay, and I guess that's basically the, yeah. This is the derecognize, this is deterministic recognize, how to recognize a given string. So not that the finite state automata doesn't give you any parsing output. It just tells you that okay or not okay, accept or reject given a string. That's how it works. But usually we need more than that, and I think we talked about that last time too. And we said that maybe this finite state automata is one way of doing a state space search. This algorithm is especially useful if you are dealing with the non-deterministic automata. And I think at the end of the lecture, I gave you this example. If this is my non-deterministic finite state automata, how would I run this through my finite state automata, and what would be the parse structure maybe? And we said that maybe just try all possible ways. If this is my input, if this is my input tape, and this is my finite state automata, at every step, okay, here there is no non-determinism, everything is deterministic. When B comes, I move to Q1. When A comes, I move to Q2. But here I have 2 ways to go. Either go to Q3 or stay at Q2. So I think there was here. Although I have 2 options, I choose option number 1. But later I realize that it doesn't go anywhere. So I have to backtracking, and go the other way. And go the other way. In this case, again, every time I am at Q2, I have two ways to go. So it's a branching factor of 2 kind of tree. So it becomes a state space search problem to see if I am leading to the end of the finite state automata, the end state. So we talked about this last time, and I think after that was it. So this is the solution. One of the biggest differences between the finite state automata, deterministic finite state automata, and non-deterministic finite state automata. Can we leave a space between you guys? That's the rule. Sorry, no, not you. Just them. One of the differences, maybe the important differences for us between the deterministic finite state automata and the non-deterministic finite state automata is there might be more than one way to accept a given string for a finite state or non-deterministic finite state automata. Okay, so why is that important? I mean, as long as I am saying accept or not, it will be important if the way you accept them is important, and we are going to see that in a few minutes. And as we said before, okay, non-determinism doesn't get us more formal power. I mean, the languages that you can express with deterministic finite state automata and non-deterministic finite state automata is the same. So why do we bother with this kind of stuff, making a search and that kind of stuff? Because writing these kind of finite state automata rules is easier for the humans. Okay, so it is easy to write, easy to see, easy to recognize for the humans themselves. Okay, so it is more natural, understandable solutions. But for the computers, it is the same thing. That's why most of the time, to run a non-deterministic finite state automata, we convert this system, this automata, to a deterministic one and run the deterministic finite state automata. Okay, so this advantage will come in situations like this. Suppose you have two finite state automata, deterministic ones, for example. I can easily combine them together into a single non-deterministic finite state automata. Okay, so I don't have to go into details of these boxes. These are just black boxes. For me, it doesn't matter. By putting these epsilon transitions or empty transitions, I can combine these two, sheep language with the chicken language, and now I have an automata that recognizes both.
So this is also a non-deterministic one, is it right?
I mean, these, I don't care if they are deterministic or not, but the whole thing is non-deterministic. Why? Because I have epsilon transitions. Epsilon means that I can go this way or that way. Okay. This is concatenation doing the same thing again. I mean, union and concatenation kind of related, but not the same. After this, I have to do this, and then I have the negation. Negation is kind of special, so this is what you do. You construct a machine M2 to accept all the strings not accepted by machine M1 and reject all the strings that accepted by M1. So what do we do? Invert all the accept and non-accept states in M1, and that's it. Okay. So I mean, remember our sheep language? Where is my sheep language? Let's go to the, yeah. This is a sheep language, right? So this will recognize B like this one, this one. These are all accepted by the sheep language. How about the negation of sheep language? Okay, this one, right? This one, this one, this one. So it's a much larger accept. So these are all accepted by the negation of the sheep language. So what do we do? All we do is very simple. Okay, this is my final state, final state, final state, final state, and this is not a final state anymore. Okay, so that's what I do. It kind of looks weird, but this is how you do the negation. So why do we need the negation? Negation is something important because by using the negation, I can do the intersection. So let's say I have two finite state automatas, A and B. Union is easy. Union is just this. Okay? But intersection is you take A, negate it, you take B and negate it, take the union and negate the whole thing again. So I mean, for a human to do this kind of stuff is difficult. looks weird too. But for computers, these are nicely defined rules, and I can definitely do them very easily. I think that was at the end of the lecture last time. So today we are going to apply these ideas to English morphology and Turkish morphology. English morphology will not be that interesting, but Turkish morphology is definitely interesting. Yes. Okay. Any questions? Maybe you will have more questions when I start talking. Wow. Okay. Here. Attendance. Sorry. So let's go to English morphology, finite state transducers, and then some Turkish morphology.
So would you upload this PDF also to Teams? Because
Didn't I do that?
I had seen only the second one. Or
I think I uploaded them. Can you check?
SRP1 and 2, yes.
You have it? But I have two. Yeah, let me upload these papers there too. Let me see if I can. Yeah, is this? Yep. So these are my class materials. Yeah, okay. Can I paste them like that? No? Yes?
Drag and drop it.
I think I drop it. Oh, okay, good, it's working. So this English morphology, finite state transducer, and Turkish morphology, okay. So, finite state methods, deterministic or non-deterministic, they are very useful in dealing with the lexicon, that is the words, okay, word structure. They are not powerful enough to express the grammar, the whole grammar of the language, but they are good enough for dealing with the analysis of the words themselves, okay? That's why we are not going to use anything more powerful than the finite state transducers. We will use this technology throughout this chapter for Turkish and for English. Okay? So let's look at this English morphology. It's a kind of, as the basic rules, they are similar to Turkish morphology. But when you come to the details or when you come to the rule sets, the two languages are very different. Okay? So what is morphology? Is the study of the words, basically. Of the ways that words are built up from similar meaningful units called morphemes. Okay? So we have the root of the word. We keep adding new morphemes to it, new pieces to it, either in front of the word or at the end of the word. You make new words, or you derive new words, or you inflect new words. Okay. When we start doing this stuff, we start from stems or roots or kök in Turkish, right? We start from stems or roots, and we keep adding these affixes. Affixes could be suffix, sonek, or prefix, önek. Okay, in Turkish usually we use suffixes, sonekler daha çok. So affixes are bits and pieces that adhere to stems to change their meanings and grammatical functions. Okay, so these are the basically things. So we are going to deal with this kökler ve ekler in morphology. Okay. So English morphology, like Turkish morphology, we can divide them into two: inflectional and derivational. Inflectional is çekim ekleri, derivational is türetme ekleri or türetme morfolojisi. Okay. In English, when it comes to inflectional morphology, there is not much going on, right? I mean, for example, if you think about the nouns book, right? Book with the morphology can be at most book and books. That's it, right? I don't have anything else. The whole inflectional morphology for the nouns are book and books. And when it comes to verbs, actually, let's think about the verb meaning of the book. Maybe I can say booking and booked. That's it. Okay. So the inflectional side, there is not much. But when it comes to Turkish, kitap is the root. Then I have all the states of a noun. Kitabı, kitaba, kitaba, kitapta, kitaptan, etc. İyilik ekleri, possessives, kitabın, kitapları, kitaplarımız, etc. So there are on the average 2 to 2,500 different forms of a noun in Turkey. So inflectional morphology is very, very complicated for Turkish compared to English kind of languages. Derivational morphology is complicated for both languages, for English and for Turkish, because with the derivational morphology, you will have many new words and verbs and that kind of stuff. For example, run, runnable, runnability, etc. You keep adding stuff at the end of the words in English. You make a noun an adjective. You make a noun a verb, from the verb to adverb, and etc. So this derivational morphology, again, for English is as complicated as Turkish derivational morphology. Yes.
How we work on the language, like I don't know any other language, but Arabic, because it has like, how could I say? There is a word and it gets different thing when it becomes a noun.
Yeah.
Not suffixes and prefixes. It only changes its shape.
Well, I mean, obviously this is not a course about linguistics. We need to know about the linguistics. Every language has their own features. Arabic kind of languages, they have their derivational rules. I mean, those are all derivational rules because you keep changing the meaning of the word when you are doing this. And actually, we have the same stuff we are using the same Arabic words in Turkish too. But when it comes to inflectional part, I mean, the Arabic is not as rich as Turkish when it comes to the inflectional part.
I mean, Turkish whole grammar is inflectional, while Arabic whole grammar is derivational. So that's.
You mean we don't talk about the grammar usually. Grammar is the structure of the sentence.
I mean,
morphology is the structure of the words.
all right.
Okay, so
Turkish morphology is mainly inflectional. Arabic's morphology is mainly
like English.
derivational.
In English, usually derivational morphology is richer. In Arabic too, but what Bilal is saying is that they don't add stuff. When you do the inflectional morphology, the whole word changes structure. Okay. For example, we know what is. Let's come up with an example in Arabic.
Kitap, katip.
Kitap, katip, kütüp. They are all from the same root, but I mean, you don't do it with the adding new stuff to the word. I mean, do you change the? So it's not, the word doesn't get longer. They are just 2 syllables again, but you say them differently. Okay, that's the feature of the language. Okay. Maybe it is easy to write poems with Arabic because you keep using the same number of syllables. So singing the same song with different forms of the same word is easier, but in Turkish the words gets longer and longer. Okay, so and this morphology depends on the number of sounds in the language too. I mean, there are some languages the number of sounds is very limited. For example, in Japanese, the number of sounds is less than the number of sounds in Turkish. So they have to keep repeating the same syllable over and over again. Or what kind of, yeah, the people in Hawaii, I think the number of sounds are so limited, so their words has to be very, very long, and they have to repeat the same syllables over and over again. Remember there was a mountain eruption maybe 5-10 years ago somewhere in the North Sea, and nobody in the world, in the newscasts, nobody in the world could pronounce the name of the mountain. I forgot the name of the mountain.
Iceland?
What?
The one in Iceland?
Do you remember the name of the mountain?
But I remember
It was like this long. Nobody could. Okay. Mountain with a long name. Mountain, okay. Mountain with a long name erupted. Yeah, this one. Erciyes is not a mountain with a long name. Yeah, this one. I don't know how to. This is Ajab file type. I don't know. So that there are words longer than. Okay, this is just a name. Usually, okay, etymology. Okay, name. Glacier of this thing. I think this language is the similar to Turkish. When you do the derivation, it gets longer and longer. Okay, and let's look at this Hawaiian names. So look at these names. It looks like they keep repeating the same syllable. It's like Turkish, right? Lots of vowels, but vowels are E's and I's, and is there an A's and I's, right? I don't see any E's in there. Yeah, there is one. Anyway, I mean the number of sounds makes the morphology differ from language to language. We are going to look at the English morphology today, then some Turkish morphology. Okay, for the study of the morphology, we are going to deal with just two kinds of words, nouns and verbs. That's it. But I mean the word classes are much larger than that. I mean if you go deeper, there are 30 classes of words. But usually there are verbs and there are non-verbs, then those are called nouns for us, and we are going to deal with these two word classes in terms of morphology. Later we will come to these word classes when we look at the structure of the sentences. Now we are looking at the structure of the words. So inflectional morphology is this. Okay, for English, as I said before, it is very easy. Okay, combination of stems and affixes. Combination of stems and affixes to produce new words, and the new word has the original meaning of the word, has the same word class as the original. Okay, so when you say book and books, they are the same word, right? I mean, one of them is the plural of the first one, and it serves as a grammatical semantic purpose, different from the original, nevertheless transparent related to the original. Books and book are, of course, they are different, but they are related to the original ones. That's the inflectional morphology. With the inflectional morphology, nouns are simple. Okay, usually we use the inflectional morphology with the nouns in English for making something singular to a plural. or possessive, okay, you will say these are my books. I made the book, the word book plural, or you could say that this is the book's cover, possessive, okay. So that's it, okay. And verbs are not that much more complicated. Again, for the verbs there is tense adjustment, tense suffixes to make the past tense and etc. The ing form, and that's it, okay, for the tense, okay. The problem here is the irregular verbs, okay. Irregulars sometimes causes problems in terms of processing this kind of stuff on computers. For example, what did I say? Book and books, just make it plural. But it is not that easy. For example, mouse doesn't become mouses, it becomes mice. Goose and goose, ox and oxen actually. And usually the most frequently used words have these kind of irregularities. These are for the nouns and these are for the verbs, okay. So go doesn't become goed, it becomes went. Fly doesn't become flied, it becomes flew, okay. So these kind of exceptions kind of makes it, I wouldn't say it complicated, but except it makes it more work for us to write the transducers or finite state automata, okay. There are many irregulars, no problem. Walk, walks, walking, walked, etc. For the irregulars, things are just, they have their own rules. Okay, so inflectional morphology in English is straightforward, not for Turkish. But it is complicated by the fact that there are irregularities. But you cannot do anything about these irregularities. They are just irregular, so you have to memorize them. Right? You just memorize them. There is no rule saying that, okay, these are the rule for irregulars, because irregulars are irregulars as the name implies. There are no rules. So, okay. So the derivational morphology is the more complicated part for English. Okay. It is a more complicated part for English because there is no systematics of it. There are no rules of which can be applied, which cannot be applied. We will see some examples. And different from the inflectional morphology, when you apply the derivational morphology rules, the class of the word might change. The meaning definitely changes. There are some suffixes that will change. For example, the class of the word, for example, book, and if you apply this able suffix, bookable is now an adjective, right? So from noun to adjective or verb to adjective. That's what we mean by changes of the word class. Here's one example. Compute is noun, verb. Computer is a noun. Computerize again is a verb. Computerization again is a noun. Okay, from verb to noun to verb to noun to adjective and etc. It goes that way. Okay. Appoint. Okay, noun. Appointee. Appoint is a verb. Appointee is a noun. Kill, killer. Okay. Fuzzy, fuzziness, etc. But I mean, this is a verb. This is a suffix. If you add this one at the end of that verb, it becomes a noun. But that suffix is not applicable for all the verbs. Okay. For example, this appoint and appointee. I know who is appointee. Appointee is the one that is appointed. Okay, but I cannot use the same rule for the verb run. Run and runny. I never heard anybody using that verb runny. Of course, if you type this to Google, I am sure somebody wrote it somewhere, but it is not supposed to happen. There is no word like running in any dictionary. Okay, so these are some derivational examples, and these are for verbs and adjectives to nouns, and these are nouns and verbs and adjectives. Okay, computational. So I mean, in this regard, English is maybe as complicated as Turkish in terms of derivational morphology. Okay, so I think we looked at this one before. This the clue could be a noun or verb. This able suffix can be applied to verbs, but if clue is a verb, nobody uses it clueable. Okay, so you are not free to make any word that you like from another word using the derivational morphology. So we are going to deal with this morphology problem using the finite state automata. We are going to give one word, okay, and we are going to ask our finite state automata, is this an acceptable word in English or Turkish? And it's going to say yes or no. Okay, that's what the finite state automatas do, right? So in that way, how many different word forms exist in Turkish? I mean, in the dictionary we have 40,000 words. For each of them we have 2,500 different forms. It's like 40,000 times 2,500 is very large number. So don't try to keep all possible word forms in somewhere. All you need to do is just keep the root and keep these rules and run these finite state automata to see if a word belongs to a language or not. That's what we are going to do. Okay. So let's do some simple stuff, especially with the English, with this minus this s suffix. Okay. It is for singular nouns, also some possessives. Okay. So this is a finite state automata to recognize a word. Okay, just a word, a noun word. Start from Q0. If whatever I see from the input is a regular noun, and that's the end of my word, then I am in an accept state and I accepted it. If they have added a plural s at the end, then I can accept too. So this path is for the regular nouns. For the irregulars, I have these. Irregular plural nouns and irregular singular nouns. Okay. For example, mice will go through here. Mouse will go through there. So the number of arcs for the irregular plurals and maybe singulars are very, the number of them is too high. I cannot put them here, but that's how the finite state automata for the plurality works. These are some simple rules. So if I do this just two, three, no. How many words are there? How many words are there in this finite state automata?
Four.
Not four. Four word forms.
These.
6 of them, okay? This one can recognize fox, cat, foxes, cats, goose, and geese.
Where can it recognize foxes? There is no ES.
What?
It cannot recognize foxes.
We'll come to that, okay? We'll come to that. He's saying that foxes are not written like this, not like, okay? So we'll come to that. So there are some, it is not as easy as this, but the idea is this. So I mean, fox is not an irregular word, okay? It's not an irregular word. Only in English, when you put an S at the end of these kind of letters, sounds, like X, right? After X, I have to be careful. What else?
O,
What?
O, S,
S, is that, what?
masses.
Yeah, S's, yes, because yes. So I cannot say S's. X, S, maybe K. No, not K.
O, I think.
Vowels, maybe, no. What? O?
O. For the
Well, for the O, I think there was a. I don't remember the third one. I think there was a third one. X, T, cat, no. With if something ends with a vowel, okay, non-consonant, a vowel. No, it's just an S. I think there was one more.
Oh, it's possible. I think goes. It gets E and S.
Really? Oh well, go. But that's
Yes, sir.
that's not a noun.
I'm trying to find a noun that ends with an O, but my
Right.
mind went blank.
Okay, it will come. So I mean, that doesn't make these kind of words irregular. They are still regular. The rule for making plural out of those kind of nouns is just a different rule. Okay, so it is not as irregular as goose and geese and kind of stuff. Okay, so these are the rules for the internal structure of the derivational structure, inflection structure of the words, and these are for the derivation rules. I have to go more abstractly. If I start with a Q0, okay, noun will get me here, adjective will get me here, then I can put this I-Z-E suffix to make the verb, and then Asian suffix to make the noun, and etc. So computerization, computerize, and computerization. Okay, so there is an adjective al. For example, how do I make an adjective from a noun using that al suffix? Tell me an adjective that ends with an al.
Verbal.
Yeah, verbalize, verbalization. Verb is a noun, verbal is an adjective, okay? Verbalize and verbalization. Another one is another al suffix. It gets me to this Q5 and verbality, verbalness. How about this one? Computerizableness, computerizably. Okay. So as you see, this is noun I, this is noun L. What do you think the difference between noun I and noun L?
What is noun L?
This is noun L, this is noun I. They both start from Q0. So what is the difference between them?
One ends with an I, the other ends with an
No. Well, I mean, kind of, but it is not that it's specific. I mean, your point is correct. These are the nouns that are in group I, and these are the nouns that are in group L. Okay? So these are the nouns that I can add this suffix to the end, and these are the nouns that I can add a tiv to the end. Tell me I think it becomes an adjective, right? Tell me an adjective that ends with an ative, attentive, right? Attend. What that? Attend is a verb.
A noun that ends with full. The
But that becomes an adjective.
no. The line of the noun L goes to Q.
Oh, yeah. So sorry. Yeah. That's true. So it is not. Yeah. So it is full. Okay. So what full? It's a noun. Tell me a noun.
Fruit. Fruitful.
Truthful. Yes. Truth is a noun, right? True is adjective. Truth is noun, and truthful makes it a adjective. And truthfulness, again, it makes it another noun. So this is the derivational stuff, and we can do this kind of grammar for English, Turkish, whatever language. And finite state automata is powerful enough to explain this. It is powerful enough to explain all this structure derivational rules. Okay, so far we only talked about what we can accept and what we don't accept. That's good, but that's not enough. Okay, usually we like to have this kind of an analysis of a word. If somebody gives us these cats, so this is what you are doing. We should say there is a root cat. It's a noun, and at the end you added a plural suffix. Okay, we like to say this. This is our analysis. Okay, to do this, we need to generalize our finite state automata a little bit, and we are going to now talk about finite state transducers. Okay, I am sure you have seen finite state transducers from your programming languages courses, right? So we are going to use finite state transducers to give this kind of parsing structure to the words of English or Turkish. But I think I am out of time for this part of the lecture. Let me stop. For once, let me stop on time. Let's give a break. Let's be here around 14:30. Ne zaman geldin? Arkadaşlar şu pencereleri açıp sınıfı bir boşaltalım ya. İyice bir cereyan yapsın. Açıkta şey falan bırakmayın, kağıt falan alır götürür bu.
Haklı değil anlamadım.
Ben de yine
Ekleri böldünüz sonra eklerle türev edeceğiz. Ama eklerle tahminlerin kısmını nasıl açıyoruz?
yani bir iki vektör çıkıyor ya, onları birleştireceğim. Yani mesela okuma neticesindekileri her bir vektörü toplayacağız. İşte kodu değiştirdim mi? Ya da
So finite state transducers is the answer to this problem. How are we gonna assign structure to the word like this one? Finite state transducer works like the finite state automata. We will have now two tapes, okay? One tape will be for the input, we are reading a string. The other one is for outputting the structure that we are trying to get. And at the end, of course, we should produce accept or no accept result too, okay? So we are after two things. One is the important thing is accept, reject, okay, state. And the second one is the structure like this, and okay. This is what we are going to, so this is the surface. Surface is the input and lexical is the output. And if this is my input, it will be cat is a noun, and then we have added a plural suffix. That's what we are going to do. Okay, so when we do the morphological analysis, we are going to use finite state transducers, and the morphological analysis is sometimes so back to this question again. Why are we doing the morphological analysis? The first one is usually this, okay? Because without doing the morphological analysis, I cannot continue with the other levels of natural language processing. Usually after the morphological analysis, we have the sentence structure. Okay, we have the sentence structure, that is the parsing of the whole sentence. After the parsing of the whole sentence, there is the semantic analysis, then there is this discourse analysis, etc. It goes that way. Okay, so morphological analysis is usually the first step, but sometimes morphological analysis is used by a standalone application. For example, our spelling correction software, right? The word spelling correction is a morphological analysis example. Okay, so when I type a word and the word is spelled correct or not, word is doing the morphological analysis. Do you want to close up windows? Yeah. Can we? Okay. So, or information retrieval. Can anybody explain this to me? And how can this morphological analysis be used in an information retrieval environment? Why do we need morphological analysis to do the information retrieval?
Is a word isn't corrected by the morphological analysis? Maybe it's mistyped.
No, it is about spelling correction in that case. This is not about spelling correction. We are talking about the morphological analysis. What is information retrieval? I am asking something I am asking information about some word, okay? And I don't have to give the exact root word of it. What did I say just a few minutes ago? A mountain with a long name, right? A mountain with a long name that has erupted, right? So I am building a complete sentence. When I build a complete sentence, I use lots of morphological derivations, inflections, etc. Sometimes you need to get to the root of the word, okay? To get to the root of the word, you need to do the morphological analysis. I mean, maybe that erupted word is not suitable to make a search. So getting the root of the word erupt is the better alternative, is the better solution. So for the information retrieval, usually they do the morphological analysis of the words that are given and choose the root of the word, okay? And sometimes when you get to the root, maybe use the vector representation of that root, and that will give you, instead of maybe it didn't say erupt, maybe it said exploded, etc. Eruption and explosion have similar, the word erupt and the word explode have similar vectors, I am sure. Okay, so whatever the reason we are doing morphological analysis, finite state transducer like this will be the way to go. And with the finite state transducer, okay, we have the, of course, states, start state, end state. There are transitions and there are transition rules, inputs and alphabet, etc. But for every step from one state to another state, there are now two things that we have to deal with. One is the input, the other one is the output. Okay, C, column C means that read C on tape, input tape, and write C to the other one. Here it means read plus N from the input tape and write epsilon or empty to the output tape, so don't write anything. Again, read plus PL from the input and write S. So we can actually, as you see, this is a non-deterministic finite state transducer. We can always run it backwards, okay? So instead of making this input and this one output, I can just switch it and run it backwards. So if I run it backwards, this one becomes our input, this one becomes our output. So that's the finite state transducer. And I'm sure you already know about this. And by using this, and at the end, if I am on a final state, then I am done. If I am not on a final state, then I reject it. If I am on a final state, I am done, and I know the structure because I produce something. I produce something. Okay. So typical uses: read from one tape using the first symbol, and write to the other one to produce our structure. Okay. And there is this problem of ambiguity again. Okay. We know that in morphology there are lots of ambiguities. Okay, there are lots of ambiguities. For example, when you wouldn't say that. For example, this, when you say books, what is the meaning of S in there? I mean, is this a plural book or books cover? You know, the possessive S. So there is this ambiguity, and that ambiguity can be only resolved by looking at the context of this word. And this ambiguity is much more pronounced in Turkish. Remember, I gave you examples of it, and there are, I am going to show you a number of examples, and I gave you those two papers. Let me show you one of the papers. Yeah, this is the classical Turkish morphology paper from Kemal, by Kemal Aflazer. This very old one, 1992 or something, but I mean, this is not, I mean, NLP-wise, natural language processing technique, it doesn't introduce anything new, but he came up with the rules of the morphology of the language. Okay, and there are some nice examples, and as I said before, I think I repeated this a number of times. I mean, talking about Turkish, a second language, in an NLP course is always useful because you can very easily show the ambiguities. Let me show you some examples. Yeah, okay. So, çocukları has 1, 2, 3, 4, 5, 4 different morphological parses. One of them is this. Çocuk is noun, plural plus, okay, it is plural, and third person singular possessive. So that means that his, her children. Another one is çocukları, is, I mean, just children, but it is accusative. That means that there is an accusative. Accusative means that ı eki, right? Dative is a eki, right? So accusative çocukları, and then how about this one? Çocukları, their child. Onların çocukları. And what is the difference between onların çocukları and onların çocukları? I think in Turkish it is the same thing, right? But well, that's the ambiguity. So this is çocuk, third person plural and possessive, and plural çocuklar, okay, third person plural and possessive. Okay, so this is can I? Yeah, it works. Yeah, okay. This is 4 different parts of the same çocukları, the word çocukları. There are even more. For example, this one is interesting, alınmış. Okay, so usually one noun, okay. The first two are noun all, or the adjective all, okay. So it is kırmızı. Then there is this noun forehead, okay, and there is verb all, and there is verb almak, alınmak, okay. So you wouldn't think about all these 8, 1, 2, 3, 4, 5, how many? 7 different morphological parses when you read this word, alınmış. But when you put it in a context, you never think about the other meanings of that, other parses of that word inside the context. Again, similar stuff for boynu. Okay. it comes from boyun, and this is what H means. It's I, E. Okay, we are going to look at it in a few minutes. This is, what is this? This is boyun, his, her neck, and I think this is boyun. It's your height, I guess. No, yeah, accusative. Your, senin boyun. This one is boyun, boyun bassın ne demek? Yani yüksekliği mi bassın, kısa mı demek, yoksa şu boyun mu? Hangisi boyun bassın? Bilen var mı? Boyun. Ha, boynun bassın derler değil mi o zaman? Boynun değil, boyun bassın diyor. O boyunla bu boyun, ama bu boyun, neck boyun. Boyun. Ne? Boyuna takılır. Boyuna takılır mı, boyuna takılır mı? Boyun. Hangi bölgesi? Boyun bölgesi. Tamam. Okay. This is that one. Okay, so let's go back, and as you see, I mean, this is much more complicated than English, because in English you have neck and you have necks. That's it. In Turkish we have all kinds of, I mean, how do you, as you see, when you say çalışmanın, to be able to say the same word in English, you have to do bring lots of words together. Of your working, çalışmanın, or of the working, or her children, or as a their child, etc. So you need to use a combination of words, and that's why, I mean, Turkish has powerful morphology, and using a single word only, you can mean many different things, and it makes it interesting. I mean, it makes it interesting, especially for the literature work, for the poems and that kind of stuff. Using this in a different manner, in a different way, gives your sentences or your lines in your poems lots of different meanings, and that doesn't happen with English. So they had to use other ways of explaining their ideas using more than one word, and that doesn't work very well in Turkish either. Okay, so I am not trying to say Turkish is better, more powerful than English or Arabic, or, I mean, these are all natural languages, and they have their powers. Of course, they have to be powerful to be used in the daily life, but their features are different. One of them is morphologically rich, the other one is grammatically rich. Okay, at the end we use them equally, frequently, often, for our daily lives, our professional lives, technical documents, literature documents, and etc. Okay, let's go back again to the slides. Ambiguity, there has to be ambiguity, and we have to deal with this ambiguity. So what do we do? I mean, if somebody tells you, okay, çocukları, okay, and you know that it is ambiguous in 4 ways, how can you resolve this ambiguity? By using the morphological analysis, there is no way that I can resolve this ambiguity. Okay, so what am I gonna do? I have to report all these 4 cases. Okay, it is either this or that or that or that. Okay, so that's called the ambiguity. And for the ambiguity, actually, if you are after accept reject strings, ambiguity doesn't make any difference for you, just accept it or not. I mean, for example, for spelling application, where is my spelling application? For spelling application, ambiguity doesn't make any difference, because as long as the word is spelled okay, I don't care if it is their children or his children, doesn't matter for me, because it is written correctly. But if you are doing the information retrieval, okay, that's going to be another matter. Or if you are going to continue with the sentence parsing, it's going to be different. For most cases, we need to find the ambiguous ways of parsing a given word, and we need to report all of them. So finite state transducer, non-deterministic finite state transducers are the way to go, but it is not enough to say just accept or reject. You have to say accept, but using this path and this path and this path and this path. So you have to find all ways of finding the except paths. Sometimes doing this segmentation or parsing doesn't produce very acceptable results. For example, unionizable, okay, unionizable. This is union is the root, unionized, unionizable, but this looks like it is acceptable too. Did you see it? This is a prefix, not suffix. In English, you do that kind of stuff. What? Anion, ion, anion. So, I mean, we don't mean to say this is like you put on in front of nouns, right? For example, what? Can we give me an example? Undone, for example. Done, undone, okay? So it is unionizable. There is no such word as anion, but the rules are allowing it. But I mean, so the point we are trying to make here is that whatever it is produced from this morphological parsers, sometimes may not be acceptable, sometimes may not be usable. But there is nothing we can do at this phase because this is a very early phase of natural language processing. Okay, so what we do in case of ambiguity, there are 4 different morphological ways of parsing çocukları. Okay, simply take the first output found. Okay, the first one, you can use it. That's good enough for spelling application. Okay, find all possible outputs and return them all. Or sometimes say that out of all different parses, morphological parses, this is the one that is most frequently used. Okay, or give them some probabilities, and we are going to see how we are doing that when we talk about n-grams actually. Okay, so ambiguity will be there. Okay, let's go back to our problem of cats and dogs and fox and foxes. Okay, so English, we said that everything is simple, but I mean it is not as simple as cats and cats because we have fox and foxes, right? So we will again use our finite state transducer idea, but we will get a little bit more smart, a little bit more organized. We won't just get one input tape and produce an output tape. We will put an intermediate tape in between them, and this will not make us more powerful, but it will make it easier for us to understand and to design parsers, morphological parsers for English. So it is called multi-tape machines, because there are problems like this and foxes, okay? And for the ed suffix, sometimes we put ed, sometimes just d, etc. In Turkish, this is even more. You don't say kitabı unless you are Zeki Müren. Zeki Müren used to say kitabı, right? Did he say that? I remember talking. Yeah, but we don't say kitabı, we say kitabı. So softening of the last consonant and etc. There are rules like this, like 22 of them in Turkish, and I'm going to show you some of them. And there are other interesting rules. For example, we like to apply this rules of vowels. You don't say you say when you say the iyelik eki possessive kitabı, you don't say kitabı, right? But sometimes you say that iyelik eki becomes ü where what çantası, it is telefonu yani it became u now, it is you, right, not so it keeps changing its form. Again, they are all part of the same possessive suffix iyelik eki. Okay, so this is even more pronounced in Turkish, but let's see it in a simple way in Turkish. So we are going to, the idea is for these, all of them, okay, we have this multi-tape machines, and this is what we are going to do. There will be one or more finite state machines. working between the surface and intermediate tape. Another set of finite state machines working between the intermediate and lexical. Okay, so by doing this, from going from foxes to fox and s, okay, at end of the word, we kind of deal with this. These are called rules, okay, rules of the language. We get rid of this problem anymore. I mean, the finite state transducer between these two tapes won't bother about these kind of rules. Okay, they won't bother about this kind of rules. So I am going to write these kind of rules in between them. This one will deal with about producing this part structure. This is a noun and plural. Okay, so one machine to transduce between the lexical intermediate level. This is lexical output, morphological output. This is the surface, that is the word that you are seeing in a regular text, and this is the intermediate result. Okay, so this is lexical to intermediate level, that is between these two. If I get an F, produce an F, get an O, O, X and X. Okay, if I get a plus N, produce epsilon. If I get a plus PL, okay, produce caret S and sharp. That's it. Okay, so this is the one that doesn't care about if I have a fox or cat, because foxes and cats are structured differently. Because this one doesn't care about it, because this one works between the lexical and intermediate level. Okay, so for it, plural means the as suffix, and as suffix sometimes work with es, sometimes s. This one doesn't care, because I already handled this between here and there. But how about this one? Intermediate to surface. So do you guys remember what I was trying to do? So there was an X, S, and Z. Yeah. This one, okay, tries to convert these foxes to fox caret S. And let's see how it works. And this is not just X, it is also for S and Z too. Okay, so let's see. Q0, if I get anything, okay, anything, I would go into this Q0 again, other than Z, S, and X. Okay, if I have Z, S, and X, I would go to Q1. If I have, for example, I have to be very careful about this. When it is past, this is a verb, right? If I like to add an third person suffix to it, I would say passes, right? So that's why it keeps repeating the same thing. And what does this one do? This one says that for the next state with an empty epsilon, with an empty transition, put a caret, go to Q2, and put an S at the end. And if you don't see, yeah, if you see an E and S from the input E and S, that means that, let's see this one. I got a Z, I came here, with an empty transition I come to here, with an ES I come to there. So while I am doing this, I produced a caret, then with an empty transition I didn't produce anything, I produced an S. Okay, so it kind of did that. So this is the regular way of going things. That's one way. And how about this one? How about this one? I am here, I transitioned with an S, I come there. Oh, okay, I saw an S, I come here, and at the end, if I have an S, I couldn't figure out this part. Can you see it? What it's trying to solve? And it's an end of the, it puts a caret, x, it gets an x. After that it says that with an empty transition, though you don't have to read anything, produce an s, and then if you see any of these z, s, and x, then you should be fine. You just continue and you finish up. I don't know what this loop is. Well, we talked about how English is easy in terms of the inflectional morphology. I mean, even a single rule like that, I mean, the words that ends with s, and z are treated differently. The finite state automata is kind of complicated to write and think about. And if you have many rules like this, in a language, then in that case, it is difficult to handle all of them in a single finite state transducer or automata. I don't know how to. Okay, do you guys? Okay, how about this one? If I have a, okay, when I say size, here s comes there, okay, and then with the s I come here, then I got an I. Can I go anywhere? I just go, okay, with the other I come back to Turkey. So, and with the other I keep doing this. And when I get the z, so any occurrences of these letters, these three letters inside the words, I would go there and I will come back. But why don't I? Oh, because this is non-deterministic. Okay. This is the path for the ET, and I did not get this part. Or go there and come back with the other. Oh, I think, yeah, I think I don't have to come back. I can move it. I can move out. I can move out with an empty transition. And with an S, I need an S in here. And I can come back. Okay, maybe I can look at this. Every time I look at this one, I get confused, but it works. I tried it many times. Okay, so it to me, I mean, this path and this path just works for everything. It looks like. Okay, so what did we do? We put something in between from surface to intermediate. It takes care of all the well, okay. Is that S E rule? This is for the E rule. Anyway, I'm not going to go back to that one. So this one handled this E rule before the S, X, and Z letters, and I got this one. For this level, it doesn't matter if I have foxes or cats. This one will work from this level to that level. That's the finite state transducer. Okay. So this one, this transducer converted these foxes to this intermediate form, and these are actually the states. It goes 0, 0, 0, and 1, 2, 3, 4, again 0. We already knew that one. And this T-lex, which is this one, okay, it just goes from 0, 1, 2, 5, 6, right? Yeah, 0, 1, 2, 5, 6, and 7. That's it. The nice thing about this structure is, I mean, this T insert, the transducer insert, is just one finite state transducer, and I can insert many of them in here with each new rule. Okay. It doesn't do anything to inputs which doesn't apply. I mean, if this E insert doesn't apply, then it doesn't do anything. It just rejects it, and we don't produce anything. Okay. So I mean, if my input is cats, for the cats there is another transducer. This E insert doesn't work for cats. Okay. This one will reject cats, but other one will work, and it will produce its output in there. Okay. If two transducers are applicable at the same time, that means there is an ambiguity, which is the case that we already know. Okay, so meaning that they are written out unchanged to the output tape, and that's good. So the overall, we now have one finite state transducer. That's explicit information about the lexicon. Okay, that is the actual words. Their spelling, their facts, and we have a larger set of machines that capture orthographic spelling rules. So the one that is working between these two are actually the ones that know more about the language, the lexicon. This one is about the rules like the drop E rule. What do we have in English other than the drop E rule? Sometimes we add these E's, okay, like the for example, ly, sometimes, yeah, tight, sometimes we add a y in between them, adding of y and etc. These are called orthographic rules, and each language has some of them, okay, orthographic rules. One of them is this drop E, and the other one is for insertion of y. The other one is doing something. There are many of them. In Turkish, there are, in the paper that I'm going to show you, there are, how many of them? There are 22 of them, 22 of these rules. So these are called orthographic rules. You put them in here, and how do you just kind of combine them, okay? Either this one work, or this one work, or this one work, and this one work, okay? So this orthographic rules are combined together. That's why we like non-deterministic automata, because it is easy to combine them in a computer environment. And we have the Lexical FST. Now this one will take this abstracted tape. I get rid of all these rules, and now I can apply my derivational or inflectional rules. Okay, this one becomes simpler. So for English, this part is again difficult, maybe not as difficult as Turkish, but it's difficult. But this part is easy, because there is not much other than the plurals and the nouns and that kind of stuff. Good. We will have this kind of structure throughout the semester, actually, the cascades. We will see this again and again. If the problem is complicated, we are going to divide it into distinct rewrite steps, and one layer will handle part of the problem, and the other layer will handle the other parts, and etc. And we are going to use these intermediate levels, or intermediate representation of the problem at hand. Other than the computer science people, nobody uses these intermediate levels. Okay, this is for our algorithms only. So we have to invent this kind of representation. For the pure linguistics, this is important, of course. This is what we see in our text, and this is important. This one doesn't make much sense. But for computers, it makes sense, because using this kind of structure, I can write these kind of orthographic rules and the lexicon finite state transducer. This is called cascade. And this cascading, okay, this cascading can be done using the rules of combination of combining more than one finite state transducer. Okay, so that's the overall plan. Write lots of orthographic rules, bring it to this level, and run your lexicon FST. Okay. Okay, so this is, and basically, I mean, when we say that one transducer, okay, works here, produces this one, and it one produces this one. So why don't we compose these two? If I have many orthographic or orthogonal rules like this, n of them, we can combine them into a single finite state transducer, right? Non-deterministic finite state transducer, using the rules that I showed you in the previous lecture. So this will make one huge finite state transducer. Again, another finite state transducer. Can we combine these two together? Yes, the answer is yes. It's called composition. Compose them together. So it's kind of the output of this transducer is the input of this one, and this composition operation. And how we do that composition? These are the rules. Okay. Create a set of new states that correspond to each pair of states from the original machines. So I have, let's say, finite state transducer here and finite state transducer there, two of them. Okay, let's say this one has 100 states, and this one has 20 states. So for each of these states, I will make a combination with the second one. So 20 times 100, there will be 2,000 new states in the combined network. Okay, so that's the called composition. New states are called XY. X comes from the first transducer, Y comes from the second transducer. Okay, and then I will build a transition table for the new 2000 state machine. But there are certain rules, I mean, easy to follow rules to create those transitions too. Once I do them, okay, there will be a very large finite state transducer, non-deterministic finite state transducer, that I can run on a standard machine, standard finite state transducer machine, and that will do my job. As a human, what I am doing here is that I am coming up with this, okay, orthographic rules. Those are the exceptions, the dropping of the inner, etc. And then I am writing this lexical finite state transducer, which produces this one. This is the easy part. And I am combining them together, and that's it. This one takes this input tape and produces the output tape. So there is no intermediate tape involved actually in the real life because of this composition. That's the idea. Okay, so this is kind of the, remember, when you do the composition, you have new set of states, 20 from the first one, okay, 100 from the second one. So XY, again, XY is a new state. For these XYs, these are your new transition rules, okay. This one says that for your new state XY, for this input there is an output, okay. For this input there is an output, okay, and your new state will be XB, YB. You do this if and only if in your first finite state automata, if your input is output for this state and your output is this state, and there is another rule in your second finite state automata, okay, it will carry your Y state to B state, YB state. You see, this is XA, YA, this is XB, YB, okay, and this input will be carried to this output. So in this case, I am going to ignore this or get rid of this C, which is part of the intermediate tape. Okay. So for some states, for some new states, XY states, there won't be any input output. Okay, so those will not serve anything at all. Those will not be reachable. So that's called composition. I am trying to make a point here. The point is to compose two finite state machines or transducers. You don't have to do anything with hand. Okay, it is all done by this nice algorithm, and there is a theory about it. Okay, and using this theory and these machines, all we have to write is, and repeat and saying again, write these rules, write this lexicon finite state transducer, and you're done. And we are doing this, all of this stuff, without leaving the framework of the finite state transducers or finite state machines. Okay, that's it, I guess. We talked about the composition, and I think I will go back to my slides and let's talk about Turkish finite state automata and Turkish orthographic rules. Any questions? Again, for that one, I uploaded this paper. For that one, I am going to use this paper from Kemal Hoca. As I said, I think this is from 1990s. As an NLP technique, there is nothing new, but I mean, remember those orthographic rules and lexicon finite state transducer. He was the first one to implement those, and he says that okay, he has 23,000 root words. Okay, and there are 22 two-level rules. Okay, for the orthographic rules, 22 of them, and then he has finite state transducers for the nouns and the verbs. Okay, and we are going to see some of them. Some of them will make lots of sense. All of them makes lots of sense, but some of them you would think that I never thought of that, etc. Okay, but so I mean, of course, this is written for the whole literature, for the whole world. So just to motivate. So this is just one extreme example. One popular and rather exaggerated. Nobody is using these kind of words in Turkish actually. Osmanlılaştıramayabileceklerimizdenmiş. It's difficult to say it. And so what is the English translation? As if you were of those whom we might consider not converting into an Ottoman. Okay, so I cannot explain the same thing using one or two words in English or in German, doesn't matter. We don't use this kind of long words, yeah, as we know that, but you wouldn't say that this is not a Turkish word. If I write this one, the speller shouldn't say anything about it, right? The speller, can I do that? Can I get this? Yeah. If I copy and paste it, do I have a word? I don't think that other than the natural language text, anybody, what happened? It's not checking you test it yourself. I think the way I'm using this, the font, okay, probably it will say this is okay. So just make sure that your spell checker works. Okay, let's take 10 minutes of break. Okay, and we will continue at 15:31.
Size mail de attım ama ya anlayamadım yani.
Çünkü bizim bir tane daha silin için kelimeleri üzerine bölüp modele bile yapıyoruz.
Evet.
O ilk zaten yazıyorsunuz. Vektörleri kullanarak binary file okuyacak bir kod yazmamızı istiyoruz.
Şey mi?
Model üretiyor ya.
Vektörlerin çıktısı.
Yap.
Onu okuyacak. Sonra aynısını bilecek.
Aynen öyle.
Yaptık mı oldu?
Yok işte ben anca anladım. Bugün anladım.
Neymiş abi?
Sırayla olayını anladın herhalde. Kelimeleri böleceğiz diye. Kelime olayını şöyle yapacağız. Bir binary file sen kelimelerden oluşturuyorsun korkusunu. Onu besleyeceksin. Bir binary olacak. O binary'yi alıp nasıl desem heceleri toplayıp senin kelimelerin
O zaman o binary'de o
kıyaslayabileceğin
heceleri tek tek bulacağım.
Aynen öyle.
Mesela okula kelimesi varsa tek tek alacağım. O şey.
Yani 12 dilimiz falan var mı?
5 ile
5 boy, 6 boy, 11 falan. Ya olabilir. Bir şeyler bilmek olmasa da olur ama.
Yani şu raptoru hesaplayacağız. Matematiksel grafik anlatımlar. Şeyleri.
Vekte olacağına benziyor. Yani.
Anlamakta haklıymışım yani.
Bilmiyorum da. Benim anlamda biraz uzun sürecek. Ben daha başlamadım. Abi şimdi şey yapıyoruz. Kelimeleri hecelerine ayırıyoruz. Onlar bir vektör olmuyor mu hep? Her biri.
İşte oluyor yani.
Oku vektörü, make vektörü, not vektörü. Sonra vektörleri toplamıyoruz.
Sonra bir şey yapıyorsun. Şimdi bir kod yazacaksın. O kelimeyi alacak, hecelerini fark edecek.
Tamam.
Heceleri o hecelerden oluşturduğun vektörlerden ayrı ayrı okuyacak, toplayacak,
Tamam.
ikisini compare edecek.
Binary ile alakalı olmuyor.
C kodu paylaşıyor da vektör. O korpus alıyor, bir binary file üretiyor. O binary file'ında vektörler var.
Anladım. Binary file şeklinde. Anladım.
O yüzden herhalde Word'deki bir kısmını kopyalayacağız yani.
Python'da mı yapıyorsunuz?
Yani ben çoğu şeyi Python'da yapmıştım ama şimdi C++'da mı C++'da herhalde Word'da. Ya onu Python içine gömüp yola bakacağım ya da
Yok kanka. Python içine gördüm. Python'da file atayım ya. O Word'dekini artık onu direkt ver.
Kanka şimdi o binary file'ı ben nasıl okuyacağım, nasıl bileceğim onu direkt vektör çok okunaklı bir şey. Ben mi yanlış baktım acaba?
Yani sen ilk çıktısına baktın mı okudun?
Baktı.
Nasıl bir şey?
Binary file bir şey okuyamıyorsun. Hexadesimal şeyler var. Yanlış mı baktım acaba?
Yok hayır. Sen çevirmen gerekiyor.
Yani hiç böyle bir şey yapmam gerektiğini düşünmemiştim. Daha detaylı inceleyeceğim de çok okunabilir
Ya
bir şey
kanka
gibi değil.
burada bir şey üretecek o kendisi artık. Onu Python'da okuyacaksın. Sen onu değiştirdikçe sonuçta değiştireceksin.
Aynen. Aynen.
Olay bu.
Peki bunları çalıştan aşağı tutar mı?
Bir şey olmuyor. Bir esas yazılır.
Okay, so let's go over the paper again. So the paper starts with the sound structure of the Turkish, and this, you know, this vowel harmony, büyük ses duyumu, küçük ses duyumu, etc. So these are parts of the language itself. These are our transducer rules. I am not going to, I mean, most of the rules are, they are written using the rules of the software, PC2Mo, which is not used anymore. It's an old one. But we kind of can understand the rules, okay? So, again, this is the transition rule. If this is the input, this would be the output kind of thing. But this one is only applicable with this condition. This is the context restriction rule, which states that the lexical A can be realized as a surface B, so lexical and surface form, only in the given left context and right context, but necessarily always. So this is left context and right context. If I am in middle, okay, I can produce B when I see this A, okay. So this one is kind of rare, and this one is kind of rare. This one is for the exceptions, okay. This is the exclusion rule, which states that the lexical A can never correspond to a surface B in the given context. This will never happen. So even if this rule is applicable, if there is such a rule, then this one says that don't apply it. So using these notation, let me show you, okay, a number of rules. But before that, okay, they introduced this 29 letters of Turkish. These are our vowels and consonants, okay, and we will, you see the structure, okay, two-level morphology, surface tape and lexical tape. He says that there is no intermediate tape in it, but you know they correspond to each other. So each one is a transducer. Okay, these are Turkish vowels, and according to your roundness of your lips, these are the round vowels and the not round vowels. So when you say o, u, ü, you round up your lips, and these are not a, a, e, etc. And your depending on your tongue, where your tongue is, the front of your tongue, okay. U, ü, o, okay, this ü and ö is front and high, u, ö. So there are three classes in it, like being round, being front, and being high. So they are all related to each other. What is büyük sesli uyumlu? With the büyük sesli uyumlu, you do this, right? This one and this one, okay, and this one and this one. So that means what? It is front minus is back, right? And so the common thing for these four is the front minus, and common thing for these are the front plus. So that's why that's how he is going to implement this vowel compatibility, büyük sesli uyum. And these are our consonants. And again, this is how you, these are nasal sounds, M and N. Without using the nasal, the burun nasal sounds, you cannot produce them. M and N. When you do this, there is no, like you cannot say M, okay, or N. And without using your dental structures, touching your dental structure with your tongue, you cannot produce N, okay. So, I mean, these are not invented for Turkish, okay. I think there are a total of 60-70 different sounds that women can make, and we are using some subset of it. We don't have all the sounds in Turkish, okay. So these are some Turkish consonants, and let's look at some of the definitions. So for the consonants, we are going to use this capital letter C, okay, for all the consonants. And VS is the surface vowels. And these are the lexical vowels. What do we mean by these? Okay. These are the surface ones. So these are the vowels that we see on the surface in the text. But these are the vowels that we are going to produce in the lexical level. So this first 8 we already have, okay. The meanings are different. The meaning of these, okay, will be given in a few minutes. For example, for this H is this, okay. H is at the context lexical level only. It stands for the set of high vowels. So these four. So it is I, E, U, Ü. Okay, these are high vowels. And A is non-high unrounded vowels. A, E. Okay. And this şapkalı, şapkalı U stand for long vowels. A, U, etc. Okay. So this one is alcohol. See, when you don't say alcohol, you say alcohol, right? So usually these are the ones that we have borrowed from other languages like English, French, etc. So this is gold, not gold, gold, right? So it is this one. So let's go back. This VV is back vowels, front unrounded. So remember that table with 8 vowels. So basically he assigned Okay, some letters for each of them. So high vowels are, let me use a different one, this one. Yellow, can you see the yellow? Yeah. And low vowels are these. Okay. So each one has a different name, and we will come back to this and see what they mean when we look at the rules. Okay, let's go back to the rules. Okay, good. Some roots have vowels which are deleted when certain suffixes are affixed. Such vowels are prefixed with a $sign in the lexicon. So they are deleted when certain suffixes are affixed. So we are going to come back to it and see which ones are there. These are lexical symbols denoting a dental stop, consonants, which has default surface realization by the voice D. So this D and T stuff, you know, sometimes what D TD yumuşaması hikayesi. So give me an example for that one.
Kağıt, kağıdı.
Kaç?
Kağıt, kağıdı.
Yes. Okay. And as never gets deleted during a fixation. For example, in the suffix, this is. Remember, H is I, U, U. Okay, siz, etc. In this case, S never gets deleted. We represent the S in the form by capital S. Let's see the examples, and we will come back to that. That will make more sense. And again, with the K and K ve yumuşak G, again we will have rules for that, and they have a different representation. And these are the rule compiler kgen heavily used in development regular expression of the sort. Okay, like that one. So let's look at these rules. This is what was A, capital A?
Was A or
A.
A?
Yeah, this one. A. This is capital A. This one says that for all A, okay, they can be surfaced as A, and these are the, remember, all the vowels, and this one, and I can do this with all the context, I guess. Let's see, I think there is first two rules force the agreement of an A vowel to the preceding vowel in the backness attributes. Backness attribute is the backside of your tongue attribute. Büyük uyum, büyük sesli uyumu, again. When you say kitaba, kitap, kitap is not a Turkish word. Anaya, right? Babaya, because the previous vowel is a back vowel, then you have to repeat the back vowel again. Anaya, kitaba, babaya. Then what else? Beze, sese. Okay, so that's the rule for the okay, backness attribute. These four are for the I. Okay, remember these are for the I. U, U, I. They will all be converted to this letter H. So actually, I mean, the first two is the definition of this one, first two, and the second, the next four is the definition of this H. Whenever you see them, you replace them with this one, but in this context only, not all of them in this context. Okay, so in a way, it doesn't matter if it is anaya or beze or sese. It is the same thing. It is the same capital A. Or sazı, sözü, sazı, sözü, kuzusu, gerisi. Okay, so these are all H. How about this one? If H, okay, this is one. Okay, that's the rule. Masam, okay, this is, in this case, iyilik eki, possessive. Table, noun, first person, singular, and possessive. This is not minus. This is first person, singular, possessive. Okay, so you don't say masaım. It is masam. Okay, and what else? But you say you don't say. You say topum. You have to put an H in there, right? Remember, U is an H. Okay, good. That's the rule. It's like, this is the rule for like the E rule, dropped E rule, or addition of the Y rule in English. Okay, when you add this, you have to H and get rid of it. U, E, U goes away. Okay, on the surface I have this one. And this is an exception. What does it say? It said, however, H vowel is not deleted in the verbal suffix yor. Yeah. Gidiyor. İyor, right? Geliyor. I don't kapıyor. I don't drop it. Kapıyor. I don't drop that E or U. Gidiyor. Koşuyor. Okay. But in this case, I kind of, yeah, kapamak. I drop this A, but there is another rule for that one. How about this one? This one is about A is dropped. What is A? A is again AE. AE is dropped. İlaçlıyor. İlaçlamak. İlaçlıyor. This A is dropped. Okay, that's that rule. This rule is VS is dropped. 0 means it is dropped. What was VS? Do you guys remember what VS is? VS is, maybe I should repeat this. Sekmeyi yinele.
Surface vowels. U, E, O, U, U, VS.
VS. Yeah, here it is. Okay, all the vowels, yeah? Surface vowels. Yeah. Okay, good. So, VS, if you see VS, surface vowels, you drop them in this context. So, burun, remember that boyun thing? Burnum, burnum, burun. You don't, you, okay? You drop both U and N. And this one will drop X. What is X? X is this one, SYN. So under what cases do we drop them, SYN? Where is it? Yeah, okay, it is. So this is evin. Huh? What did we drop here? Ev. Oh, okay. This is evin. Evnin. Kapının. Okay. This is N-I-N suffix. But if you combine it with a word that ends with a consonant, you drop that N. So this X is S-Y-N, right? You drop S, Y, and N. Okay, it goes like that. There are 22 rules like this. And these are carefully written. And when you apply them to your surface forms, you get your direct lexical forms, or maybe you can say that we are not using exactly the same terminology. This is all intermediate level stuff. Okay, so by doing this, okay, I get from here to, okay, from here to maybe this part, or from here to maybe this part, okay, from this one to this one. I still didn't assign all the parts yet, and we are going to do it in a few minutes. But I have to standardize my input so that I get rid of, I mean, for me, evin and kapının are using the same suffixes, even though they look very different. So foxes and cats, they are using exactly the same suffixes. In Turkish, we have different orthographic rules like those. You have a question?
22 rules for the entire
Morphology, yeah.
Wow.
Yeah. And there are, of course, many exceptions, especially exceptions with the foreign words, words from Arabic, words from English, French. They are making lots of exceptions. And for English, you don't have this many rules, I mean 4 or 5 at most. Okay, and these are the rules actually they teach you in high school or middle school about Turkish, right? Yumuşka, yumuşaması, something, something, eklenmesi, etc. and etc. And these are the ways of writing the same thing using using this what was the name, PC something rules. Okay. Okay, this is D and T. You get what is D? D is here to D. No. Couldn't find D.
Capital D?
Yeah, I think it is defined somewhere. Here, D is a lexical, yeah, DT stuff. Remember that DT stuff? It is defining that one. Okay, kitap, kitap, kitab da, kitap ta. Okay, so you are changing it. Yulaf, yulaftan, yulaftan. Açtık. Okay, this is TH stuff. So I am going to move a little bit faster. So this is JH stuff, and it is explaining both of them in any context. This is K yumuşak G again. Do we have, okay, this is an exception. See, do this, but under this kind of cases, don't do that. And usually this happens with the foreign words. Okay, we don't have any, I guess, words that ends with a G, but these kind of words come from the other languages. Radiolog, you don't say radiologa, it becomes radiologa. Okay, but when it is briefing, you don't say briefing, you say briefing. Iceberg. Okay, icebergin is. So even if the words from are foreign words, you have some rules for those. And 22, finally we have a cleanup rule to remove apostrophe from lexical proper noun under certain circumstances. Remember when we say İstanbul or Gebze'den, to remove that one from the surface form. Okay, so these are the rules again that will carry us from the surface level to this intermediate level. Now we are going to work on the real lexical rules to the parsing. Let's look at those. By the way, they say that, okay, these are the stuff. Remember, we had only 2 word classes, verbs and nouns. Okay. In these rules, we have nouns, adjectives, verbs, isimler, sıfatlar, fiiller, bileşik isimler, özel isimler, zamir, zarf, bağlaç, ünlem, postpositions, postpositions ile preposition is for him is a preposition, right? Postposition happens in Turkish, not in English. Ahmet ile acronyms and kısaltmalar. Technical jargon special cases are the types of the word classes for this system. Okay, so let's look at the finite state machine for morphologic analysis. Okay, again the rules are in PC Chemo. Let's start with, okay, these are our lexical words. Okay, there are 27,000 of them. I think I was asking what is the first word in the dictionary. Somebody said abajur. Not bad, okay, but the first one is ab, which means, I guess, water, yeah. And the last one is zuyuf. I don't know what zuyuf is. Okay, zurriyet we know, at least I know. I don't know what zuyuf is. Okay, so these are there are 24,000 line here, because these are the nouns, and there are 4,000 or 5,000 verbs. And these are the ones, okay, lexicon postnoun, lik, ji, jik, lash, etc. Okay, so this is L, remember H? H is all the I, U sounds, etc. R is A and E, etc. Okay, so finite state machine for nominal morphotics. Okay, nominal means that it is a root form. Let me show you for the finite state machine for the verbs, and here it starts. Let me show you the whole thing first. Okay, it ends, but this is for the noun and this is for the verb. Okay, so you start with a nominal root, verb root. Okay, nominal root, and you start with it, and if you continue this way, for example, lash, la, lan. Okay, give me an example that ends with a lan. Lan. Aklanmak, çullanmak, kötüleşmek, etc.
Farklılaşmak.
Farklı is the no, if you consider as a root, yeah. So I start with a nominal root, okay, and then maybe yours is like this side. Farklı is here. Is l here? No, look. Sabahlık, lash. I just made a word, okay. Okay. And then I have this large stuff. What is this? This is nominal. Okay, this is not sorry. This is for the verb, not verbs, for the nouns. This one is right. Okay. So I start with noun, and I do these things again. I become a nominal root, and this is a verbal root. This becomes verbal. Then I become plural. Sabahlar, and if I add sabahlarım, sabahların, sabahlarımız, sabahlarınız, it becomes possessive, and it becomes an accusative noun. Accusative means dative means e hali, accusative i hali. Okay, and sometimes sabahlarca becomes zarf adverb. Sabahlarsı, what is possessive? Oh, sabahları. Yeah. What is the difference between this one and this one? This is your sabahlarım, sabahları, and I think there is a dropping is happening. sabahlarını and accusative noun. Okay, so this case 1, case 2, case 3 stuff, they will have to explain it later, case 1, case 2, okay? So this is not exactly finished because this is all repeating here. So they took it out and put it in a different place. Okay, so these are my end states. Okay, I start with a nominal root and I end up with accusative noun. Okay, iyi hali noun, zarf, nominative case noun. Okay, sade hali, zarf, accusative noun again. What else do we have? Yeah, we have temporal adverb, can. How do I come to this one? Can. Something noun.
From case 1,
Sabah. Why does that sabahları? Where do I come to this one? Sabahları. Sabah. Just empty transition. Sabahlarıyken. I don't know. It's a temporal. Koçlarıyken yaptı. Somethingken yaptı. Okay. So this is a temporal adverb. And this one is nominal verb. I made a verb out of here. Nominal verb. Attitude adverb. And nominal verb. So it is not that easy to follow, and it is definitely difficult to debug all this stuff. Remember the finite state, automata, non-deterministic. This is definitely finite, non-deterministic, right? Why? Because see this one? This is empty transition, right? This is empty transition. And also, I can sometimes, with the same input, I can sometimes go one way or the other way. Can I find it in here? Okay, like for example, this one and this one. No, not that one. I'm sure there are cases like those. I can go that way or this way. But at least I know this one, right? There's empty transition and empty transition. And there is always possibility of producing different results for the same input. So this is about nominal morphology analysis for the nouns. Let's look at the verbs. Verbs are here, verbal root. Okay. Let's look at the end states first. Okay, this is adverb. I don't know what this is. Adverb again. From verb to verb, other stuff. And these are the continuation of that stuff. Verbal stem, negative stuff. Where is verbal stem? Where is verbal stem? This one ends here, and I'm going to continue. Yeah, it is okay. It is. I can continue from there to do more stuff. And let's see what kind of things. Verbal root, koş, koşun. Is that yeah, koşun? Okay. Koşuş, right? And koşuştur. Koşuş. What is this? But this is koşuş. Oh, koşuşu. I don't know what this one is.
This is edilgen, I think.
Yeah, passive, but koşuşu. What is what? Did we do it right? This is koş, koşun. Koşun. Kaşı, kaşın, kaşındır. Kaşındırt. Huh? Like that. And I can call you say this one? Remember that one? Kaşındırt. Okay, so these are the rules for the verbs, and I don't have time to go over them, and most of them I don't understand. And I think I'm going to look at, okay, these special cases. I think these are not following any rules, so they made it. I mean, this one, it looks like Turkish word, but for some reason there are some exceptions. I understand this one. Sanayi is not Turkish. Mevki is not Turkish. Okay, but I don't understand these. Birer, ikişer, ellişer. These are as Turkish as anything, right?
Maybe it's something like you said that in oftenly used English words, the verbs become C, so something.
Well, that's for English, but that's not Turkish. I mean, in Turkish, the most commonly used words are most strong, strictly following Turkish. I mean, yeah, when we say anne instead of ana, but that's just wrong usage. I mean, that's the Istanbul Turkish. What else we kind of do that kind of stuff? Ana is Turkish, anne is not Turkish. Alma is Turkish, elma is not Turkish. But nobody uses elma other than us. I mean, we didn't import it from somebody else. I mean, kind of, I don't know why. I mean, this westernization of the Turkish language happened a lot in 18th century. Okay, usually we didn't have that many T's in the language. It was all D. At the end of it is not Hamid, it is Hamid. It ends with T. So for some reason, just to make it look sound like French, we started adding stuff like T's at the end. I think elma become elma during those days. The correct one is alma. The correct one is ana, right? I don't know why we say elma for some reason. It just happened. But I cannot explain. I mean, nobody designed Turkish, right? I mean, nobody has to follow these rules. Turkish doesn't have to follow rules. I mean, Kemal Frezer came up with these rules in 1990s. Okay, he used lots of other sources to design all these rules. That doesn't mean that Turkish has to follow these rules. If you come up with a different set of rules, maybe these will be in the rule set. Okay. Somebody was saying to me that geliyor, I don't understand why when we say geliyor, we don't say geliyor, we say geliyor, right? It doesn't obey the büyük ses duyumlu rule, okay, for some reason. Somebody told me that is not a suffix, it's a different word. Geli space yor. Yor is a different word. And I think in some Anatolian dialects, you don't say geliyor, they say geli yürü, gidi yürü. I don't know where, I think I heard it in some movie or something like that. So we kept changing the language, our language, grammar-wise too, just because we should sound like French or English or something like that maybe. I think it is French. When you say geliyor, gidiyor, it sounds like French, right? French songs. Sometimes, do you know French? You know French?
No.
Anybody knows French? If you listen to French songs, their songs are very similar to Turkish songs. I mean, our Turkish songs are similar to French songs. If you try to make your language sound like one of those languages, it will happen not in 10 years, maybe not 10, maybe in 2 or 3 generations it will change. Okay, so let's look at some of the examples again here. So çalışmanın, so that's why I like this one. Çalışmanın, okay. So it has 2 meanings: of your working and of the working. Okay, and first, okay, you see this one? This is my input, and this is my morpheme structure. This morpheme structure comes from the rules of that 22 rules. Once I get this one, okay, once I get this one, both of them, now I can do this, tag assignment. It is root, okay, this is verb to noun, ma, okay, and then I have second person possessive and genitive. Genitive means this suffix is genitive, okay, and then relating to. Okay, çocukları we already did, ödüllendirmiş. We looked at these, right? Alınmış, boynu, etc. So the morphology is something interesting, and the nice thing about it is you don't need any artificial intelligence related stuff to do the morphological analysis. The only thing that you're going to use artificial intelligence is to disambiguate one of them, okay? When you say alınmış, which one do I mean out of these 7 different parses? That's where we are going to need artificial intelligence, and that's where we are going to, we need to look at the, that's why we are going to look at the context of the word. I mean, the important thing is the sentence itself. When you look at the sentence, sometimes, for example, okay, this is a verb, right? Somebody alınmış. Adam bana alınmış, haberim bile yok. Okay. And then direğe çarpan alınmış. It's a noun. Okay. So by looking at the context, by looking at the sentence, you can figure out the sentence structure. By looking at the sentence structure, you can figure out the role of this word inside the sentence. You need to do more processing, but at the beginning, by looking at a single word, you cannot say it. Maybe you can say stuff like this. I looked at least 100 different cases of this word alınmış in my corpora. Okay, I don't know how many words are there in Wikipedia alınmış. If somebody finds all the words alınmış in Wikipedia, and if they mark them with either this one, or this one, one of the 7, and then you will say that okay, this is the one that's going to be. But that's a very rare case, right? I mean, how many times do you think alınmış happened in Wikipedia? When you say alınmış site, what was the site for the Wikipedia?
tr.wikipedia.org.
Really? Okay. Did I spell it right? What? There are 36,000 of them. Really? Korunmaya alınmış yazılar. Okay, most of them is, which one is this? Korunmaya alınmış kablolar, korunmaya alınmış sayfa, korunmaya alınmış, it is all alınmış. Okay, so it looks like for the Wikipedia, I wouldn't have guessed it, but alınmış means, which one? Where did my, okay, it is. Alınmış means, I think, I guess this one.
Hey,
Yeah, I guess this one. Alın, passive, and verb to active adjective. Okay, third person. Yeah, this one. Yeah. So most probably it's going to be that one for Wikipedia, though. I mean, I would have guessed it would have been this one, alınmış. No. I think I would have guessed it was this one. Okay, so looking at the statistics, you can assign one value to that. But as I said, I wouldn't expect 36,000 happening in Wikipedia. It would usually happen 10 or 15 times because these are very rare words. So what would you do? I would look at the frequency of these suffixes, right? This one. Which one is happening more after this kind of a verb? So that would be a better solution. And the other thing is that somebody has to go to Wikipedia, Okay, somebody has to go to Wikipedia.
And mark them by himself.
Why? Okay. Somebody has to go to Wikipedia and that person has to morphologically analyze these kind of words and choose the correct one by one. Right? So who's going to do it? It requires lots of labeling, and that's going to be kind of tough. Okay, so what else? I think I covered all of them, and these are the conclusions. There's some advanced stuff. Do you guys remember the online morphological analyzer that I showed you before? Where is this one? Stiff thing. By the way, if you are not sure about some of the Turkish rules, this is a very good site, Learn Turkish. And these are some of the rules. For example, Control F. Yeah, dative case suffix, dative as I said before, hali, okay, and I think there was one genitive. Yeah, this is this one. None, you see, something related to anahtar, arabanın, anahtarlar evin. So these, of course, this site is not for computer scientists. This is for people. But these are the rules. These are the rules. Just go over the rules, and sometimes you would be surprised that you did not know or you did not realize that you applied those rules. Okay. So if you are going to take an exam like YDS, Yabancı Dil Sınavı like Turkish, YDS. So these are the things that people. Oh, see this one? Negative aorist. What is it? What is aorist? Negative turn. Mem, yapmam. Mezsin, mez. What is aorist then? What is this? I don't know what this is linguistically. Or I forgot. Positive regular aorist, okay. Yaparım ederim, okay. Sabah giderim. So I thought that this is regular present tense, right? Something different. It's called positive regular aorist. Anyway, so let's go to this TR morph. Let's go to this TR morph. Let's go to this TR morph if I can find it. I guess it is here. And now we can do, see, masaları. As we did before, okay, I'm out of time. As we did before, there are many parses of it, morphological parses of it. Some of them are exactly the same. Okay, so due to some problem with the software, I don't know, but it's very useful to test this. Okay, masa noun and plural and accusative, ihali. Masa. So what is the English corresponding English word for this one, the first one? How do you translate this one to English? Masaları. Dear, his tables. His tables, right? But it means I saw his tables. It's not like just I saw his tables, and I painted his tables are two different his tables, right? In English, one of them is accusative, the other one is dative, I guess. So his tables. How about this one? Masaları. No, this is no. This is his tables.
This is masa. The first one is accusative, masalar.
Yeah, the second one is his tables, right? Second one is his tables. The first one is şu masaları getir. Yeah. Bring me the tables. Okay, the second one is tables. How about this one? Their tables, right? This one is, oh, it's the same thing. How about this one? Masa, it thinks that masalar is another noun. Yeah, it goes that way. Do we have any interpretation about the verbs now? Yeah. Okay, there is masaları. I don't know where. Sometimes it happens with some of the nouns, but it doesn't know. Remember noun L and noun K? Okay, this one doesn't have a very good rule set to the distinction between the noun types. Sometimes it happens that if you do this, plural and accusative, it makes a verb, but in this case, within masa, it doesn't happen. Okay, I guess that's it for today. So I finished up with morphology. Next week, I will start with counting words and letters and the syllables. Okay, counting is our main tool for the statistical natural language processing, and that's what we're going to do. And we will come back and we will do this a lot. Okay, any questions? Okay, did everybody sign the attendance sheet? Ne zaman geldin sen?
2 saatte geldim.
Geç kalmayın yani. Hangisi bu?
Ya otobüsü kaçmış.
Evet. 25 Mart. Ha? Anlamadım.
Otobüsü kaçmış.
Tamam.
Ne kadar çalışsın, ne kadar çalışsın. Ona göre kaç saat çalışsın.
Ne iş yapıyorsun?
Emin hocam.
Hadi görüşürüz.
Şeyden göre orada sen yaptın. Üçüncü sınıftan başladın.
Birin yazında işte bir yaz stajı yaptım gönüllü.
Ne zaman?
Birin yazında.
Efendim?
Birinci sınıfın yazında.